Our journey begins approximately 4.5 billion years ago, in a time when the universe was still young and full of potential. The solar system was a chaotic nursery, a place where the building blocks of planets and stars were just beginning to take shape. Dust and gas swirled in the vastness of space, creating a cosmic dance that would eventually lead to the formation of our solar system. This cloud, called a solar nebula, collapsed under its own gravity, pulling material inward and setting the stage for the birth of a star. At its center, a star ignited, our sun, a beacon of light and energy that would become the heart of our solar system. Farther out, the swirling material coalesced. Planetary embryos formed, small but significant beginnings of what would become planets. These embryos, through countless collisions and accretion, eventually gave rise to the planets we know today. Among them, our Earth, a unique world in the making. The early Earth was a molten ball of rock, bombarded by asteroids and comets, a violent process that shaped its surface. This constant bombardment generated immense heat, causing the planet to glow with fiery intensity. Volcanoes erupted, spewing lava and gases into the primordial atmosphere, creating a toxic and volatile environment. It was a hostile and alien world, unlike anything we can imagine today. Yet, within this chaos, the seeds of life were sown, setting the stage for the incredible journey of life on Earth. The Hadean Eon, spanning from 4.5 to 4 billion years ago, was a time of intense heat and volcanic activity. The Earth's surface was a magma ocean, constantly churned by impacts. As the Earth cooled, a crust began to form. Water vapor, released by volcanic outgassing, condensed in the atmosphere. Torrential rains fell upon the cooling crust. Oceans, the cradles of life, began to form. The Hadean Eon was a time of immense change. It was a period of intense bombardment, volcanic activity, and the formation of the Earth's crust and oceans. While no life could have survived in this harsh environment, it set the stage for the emergence of life in the next eon. The Archean Eon, spanning from 4 to 2.5 billion years ago, witnessed the emergence of life on Earth. The first life forms were simple, single-celled organisms called prokaryotes. They thrived in the primordial oceans, feeding on the chemical soup of the early Earth. These organisms left behind the earliest evidence of life on Earth, fossilized stromatolites, layered structures formed by the growth of microbial mats. The Archean Eon also saw the formation of the first continents. Volcanic activity continued, releasing gases into the atmosphere. However, the atmosphere was still devoid of oxygen. The early prokaryotes survived through anaerobic respiration, a process that does not require oxygen. The Proterozoic Eon, spanning from 2.5 billion to 541 million years ago, was a time of significant change. Life evolved from simple prokaryotes to more complex eukaryotes. Eukaryotes possessed a nucleus, which contained their genetic material. This innovation paved the way for the evolution of multicellular life. One of the most significant events of the Proterozoic Eon was the Great Oxidation Event. Around 2.4 billion years ago, a new type of organism evolved, cyanobacteria. Cyanobacteria were photosynthetic, meaning they could use sunlight to produce energy. A byproduct of photosynthesis is oxygen. As cyanobacteria proliferated, they released vast amounts of oxygen into the atmosphere. Section 5. The Cambrian Explosion. Life explodes. The Phanerozoic Eon, which began 541 million years ago and continues to this day, is characterized by the diversification of life. It is divided into 3 eras: Paleozoic, Mesozoic, and Cenozoic. The Paleozoic era began with the Cambrian Explosion, a period of rapid evolutionary diversification that saw the emergence of most major animal phyla. During the Cambrian Explosion, life developed hard shells, skeletons, and complex body plans. This led to an explosion in diversity, with creatures evolving to fill every niche in the oceans. The Cambrian Explosion marks a turning point in the history of life on Earth. It was the dawn of the Age of Mammals. Section 6. Paleozoic Era. From sea to land. The Paleozoic era continued with the Ordovician, Silurian, and Devonian periods. life continued to diversify. Fish evolved jaws, becoming fearsome predators. Plants colonized the land, followed by arthropods, the first animals to venture onto dry land. The Devonian period is known as the Age of Fishes due to the incredible diversity of fish species that evolved. The Paleozoic era ended with the Permian-Triassic extinction event, the largest mass extinction in Earth's history. Volcanic eruptions, climate change, and ocean acidification wiped out over 90% of marine species and 70% of terrestrial species. This catastrophic event marked the end of the Paleozoic era and paved the way for the rise of the dinosaurs. Section 7. Mesozoic Era. The Reign of Reptiles. The Mesozoic era, spanning from 252 to 66 million years ago, is often called the Age of Reptiles. Following the Permian-Triassic extinction, dinosaurs emerged as the dominant land animals. They diversified into a wide array of forms, from the massive, long-necked sauropods to the fearsome theropods like Tyrannosaurus rex. The Mesozoic era also saw the evolution of birds, the descendants of theropod dinosaurs. The first birds, like Archaeopteryx, had feathers, but retained reptilian features like teeth and claws. In the oceans, marine reptiles like ichthyosaurs and plesiosaurs ruled the waves. The Mesozoic era ended with another mass extinction, the Cretaceous-Paleogene event caused by an asteroid impact. Section 8. Cenozoic Era. The Age of Mammals. The Cenozoic era, which began 66 million years ago and continues to this day, is known as the Age of Mammals. This era marks a significant period in Earth's history, characterized by the dominance and diversification of mammals. With the extinction of the dinosaurs, mammals, which had existed alongside dinosaurs but were relatively small, were able to diversify and fill the ecological niches left vacant. This allowed them to evolve into a wide variety of forms, from tiny shrews to massive mammoths. The Cenozoic era saw the rise of primates, the lineage that eventually led to humans. These early primates adapted to life in the trees, developing traits that would be crucial for their survival and evolution. Early primates were small arboreal creatures. They had grasping hands and feet, which allowed them to navigate the forest canopy with ease, and their keen eyesight helped them spot predators and find food. Over millions of years, they evolved larger brains, more complex social structures, and eventually bipedalism, the ability to walk upright on two legs. This significant evolutionary step paved the way for the development of early human ancestors. The Cenozoic era is also characterized by a series of ice ages, periods of global cooling that shaped the Earth's climate and landscapes. These ice ages had a profound impact on the evolution and distribution of life on Earth, influencing the habitats and survival strategies of many species. Section 9. Earth's Resilience. A Story of Adaptation. From its fiery birth to the present day, Earth has been a planet of constant change. The early days of our planet were marked by violent volcanic activity, with molten lava shaping the landscape. It has witnessed periods of intense heat, volcanic eruptions that spewed ash and gases into the atmosphere, asteroid impacts that caused massive destruction, ice ages that blanketed the planet in ice, and mass extinctions that wiped out countless species. Yet, through it all, life has persisted, adapted, and diversified. From the simplest microorganisms to the most complex ecosystems, life has found ways to thrive. The story of Earth is a testament to the resilience of life and the power of evolution. Fossils tell us about ancient species that once roamed the Earth, and the thriving ecosystems of today show us the incredible diversity of life. As we look to the future, we can draw inspiration from Earth's past. The natural landscapes that we cherish today have been shaped by millions of years of change. Our planet has faced and overcome countless challenges. Natural disasters like wildfires, floods, and earthquakes have tested the resilience of life, but recovery and regrowth always follow. It is a reminder that change is inevitable and that life finds a way. Plants and animals have adapted to survive in the harshest environments, from arid deserts to frozen tundras. By understanding Earth's history, we can better appreciate the delicate balance of our planet and work towards a sustainable future. Scientists study the past to learn how to protect our environment and ensure that life continues to flourish for generations to come.